View of the paper, not all language model features are linear. The linear representation hypothesis has been widely discussed in recent studies, which suggests that language model perceives various concepts as one-dimensional numbers, like this. In contrast, this paper explores whether language models can perceive concepts in a multidimensional manner. Multidimensional perceptions by language models implies that these multidimensional features are irreducible. Irreducible meaning they represent the minimal unit of concept. Mathematically, irreducible refers to dimensions that are independent or non-co-occurring with each other. This paper proposed a method using SAE, sparse autoencoders, to automatically identify irreducible multidimensions and presents experimental evidence that language models indeed perceive concepts multidimensionally. The research falls under a branch of study known as mechanic interpretability. This approach seeks to explain the inner working of language models by treating them like machines, dividing them into variables and programs. Scholars in this field are said to be divided into two groups. First group, supporting the linear hypothesis, and the other, supporting the multidimensional representation hypothesis. However, this paper reveals that when language models process complex data, they do not simply use linear structure, but also employ more complex frameworks. So they are positioning their research work as a potential bridge between the two perspectives. The contributions of this paper, as argued by the researchers, are as follows. First, expanding the concepts from dealing with only one-dimensional features to also addressing multidimensional features. Second, proposing a methods for automatically identifying multidimensional features using sparse autoencoder. A third, providing experimental evidence to support their claims. Definition first is essential for conceptually explaining why we can assume that not only one-dimensional but also multidimensional representation can be used. To explain this definition more clearly, the function f maps the input space to a df point cloud with a probability greater than 0 but 1 minus s percentage. Only 1 minus s percentage of this attribute in input space only can be mapped into the point cloud. In deep learning, the mapping is often described as activation. So these are activation attributes. However, if everything were mapped to a one-dimensional point cloud, what would happen with the concept of the day or month? Due to the linear nature, Monday might be positioned on the left, but while in reality it should also exist on the right of the Sunday, here. Therefore, the assumptions that the dimensions of LLMs are not one-dimensional but multidimensional is quite formal and well-grounded. Something like this. So conceptually, it makes sense that multidimensions exist, but what features should we look for to determine if they actually do? First, let's define what a feature is. As shown in equation first, a feature f is computed by multiplying in the input by a matrix R and adding a constant C. In this way, when the model receives some input data and captures important information, we refer to that as a feature. However, the features we are looking for must be irreducible. Irreducible means that a particular feature cannot be further broken down into a simpler components. Mathematically, this means it must satisfy the following two concepts. Equation 1 describes a case where the multidimension can be split into independent subspace. Equation 2 states that the various components must never occur simultaneously. In other words, to determine if a multidimension is irreducible, we need to check whether the subspaces are independent from one another or if they do not co-occur at the same time.